Alright, hello everyone. Professor Caudill. And today we are on I did want to show you. So this is the code I would say mostly made by myself. This is mostly made by the chat bot, but I don't like this one, so I'm just gonna delete it. So this is mostly done by me. Um, so yeah, want to take this. So I had the chatbot just like I copied all this, posted it in the chatbot. I asked it to revise, or I asked it to shorten the code. So this is what it gave me. Um, so it's got a substitute. So I guess it missed the F1 and 2. That's why I paused. I was like, why aren't these here? So I will have to probably add those. It's probably guessing like, oh, it's just doing this. But anyways, it's got like this special function here that takes the equation, substitute a dictionary. So this dictionary is here. So it's substituting that for that, which is like, that's pretty cool. And then it's got um, this special function here might need change because we might want like a solution one, because if we get 2 square roots of time, so on the surface it looks a lot better than this, but like this we might need to actually like mess with this more, but it looks way better, like it's more simplified. um yeah, so all right, let's get into it. Where should we start today? um I guess we'll just start with constant motion with constant acceleration. Particles moving. So I think the book just said somewhere outright that velocity is a vector because it has a direction. So I was thinking about this earlier. So a vector might be a list of numbers. Okay, so a a vector function would be some change to this. So it could be which means 5. So if your input is that, then you might output. So I don't know if I haven't like seen like any this in the textbook, but it's like I'm trying to bridge the gap between just regular one-to-one functions and matrices. Because I think high school algebra uses R1. So the set of real numbers, so that's uh, -3, -pi, 0, 1, e, dot, 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 and everything in between. So if you're doing this function, if you had this, so this would be an R3 because there's only 3 components. Okay, so that means this would be an Rn. And if you wanted it like a vector, like what's R n by m? So that would be, you have like a set of numbers, -1, 0, you like dot dot dot, -1, 0, 1, dot dot dot, and then similarly 1, 0. And then a bunch of dots. So I think that might be, I'm trying to think of like the most abstract real number space you could have. So here would be your x, y, z line, maybe. But then you also think of like x, y, z as, you might see like x, y, z, and then you have your direction, unit vectors. So yeah, let's let's do 43. Particles going 30 meters per second. So we're gonna say that's a vector displacement. So displacement between these times. So we're gonna take displacement function. We know x naught is 0. We know so they want displacement. So we're gonna use x. I'm pretty sure. Ah. All right. So which of these is for displacement? Okay, x equals x naught plus t. So if you watched the last video, I got very stuck with the definition of average velocity. Does it seem, does there seem to be two definitions for average velocity? One definition divides ending velocity while another definition takes or two different definitions of average velocity depending on the context and assumption. Okay. So like it's like I don't know how you do this. Like so this would be 5 plus I think our initial velocity would be 30 as well because it says it's moving at a constant. But do we add the effect of gravity as well? It's not specifying the environment, but anyway, this might be 30 or this might be change in position, which is I guess we don't know. I guess we don't know. He went 30 seconds in 30 meters per second, 5. Okay, so x 0 plus 30 times 5. Okay, so that makes sense to me. Um, it's not accounting for gravity. It's like the particle be doing this if there's a force of gravity. Um, I'm gonna assume no, because like the only thing it says about the environment is it's a straight line. So displacement is 180. 5 times 3 is 15. 30 times 3, 15. 150 meters. Okay, that makes sense to me. Um, I think it would help if we labeled these. So I want to do print What is so shouldn't we swap these? Like, wouldn't you want to define this before this? That would make sense to me. So this equation determines average velocity. This determines displacement. Okay. And this. Okay. Final velocity. Let's see. I don't know if I like this. Alpha squared. Determines average velocity. Okay. Um, Determines displacement. Then we have equation of motion and velocity. AT, equation of motion. All right, 44. Particle moves in a straight line. V naught equals 0. It's moving 30 meters per second. There's A. Okay, so we're going to use which equation? So we are probably going to use equation 4. So we're going to do F4, and our variables are x. We're solving for x. Solving for x. A is 30. T is 5. 0, 0. It's 375. Okay. Maybe I can verify. We get 375 as well. Our calculator is working. Particle moves, so we're doing 45. Particle moves in a straight line. The initial velocity v naught is 30. A is 30. Okay. So we want to find displacement. So we need to know not x not 0. I think we can just say x naught is 0. Okay, so we want to find displacement. So these both determine displacement, don't they? So we could do thirty times 5 squared over 2 plus 5 So t, I'm thinking it's t end minus t beginning. All right, so we're using equation 4. So our acceleration so similar to the last problem, except we're changing the initial velocity to 30. So now it goes 525 meters. If it's got a running start. Okay, 46. Sketch a graph of velocity versus time. I don't like doing these. Sketch a graph. No thanks. Let's do 48. So constant acceleration, A is 6. If the initial velocity so now we want to solve for t given x is 5. Okay, so we're going to use, I think, equation 4 again, because this time we know x is 5, a is 6, t is t, so what we're solving for. V naught is 2, x naught is 0. So again, we can't get negative time, so this is what I said earlier. Oh, I put the wrong equation, didn't I? That's awkward. Sorry, I meant use this code. Okay, so this says 1 second. I want this to output both solutions since velocity can be negative, can't it? So 1 second. So it does this in 1 second. Right, and I think they wanted the velocity as well. So now we know 1 second, so it's going 6 times 1 plus 2 equals v, so it's going to be 8. Okay, 49. So at t equals 10, particle is moving left to right. So its velocity is -5. T is 20. It's moving 8 meters per second. Assuming the particle acceleration is constant. So A is 1. 1's a constant. Oh, we have to find A. Okay, so finding, we want to use, we have acceleration, so we know it's probably this, right? We have T, it's 5. Okay. So I'm thinking we do V, the ending V is A. So I'm thinking 8 equals A 20A using equation 3. But I don't think we know the initial velocity though. It's like this question is really confusing me. It's initial velocity. What do they mean? Like at t is 0? Is that what it's asking for? Maybe we find V average. Here we want to solve for A, so it should be V. Should be 8 equals time. So wouldn't that be 10, 20 minus 10? So 10A minus 5. Thinking it would be that. So we're using equation 3. So equation 3, we're going to do V is 8A and -5. Okay, so we get 13 tenths. Um, okay. Answer is 1.3. So getting, what did we just solve for? A. Okay, now we want to get V naught. So we want to find V naught. So if V is 8, so now we're gonna do 8 equals 1.3 time full time. It's at 20. 20 or 10. I think they want V naught like V naught at 0. Okay, so we're gonna try 8, 1.3, 20. So V not specific, it's negative 18. Okay, so it's it when its velocity is 0. So V is 1.3 t minus 18. So what's and so when the velocity is 0. It's asking about this. So 1.8. It's probably like 15. Probably about 15 seconds. Seems reasonable. Okay. A is this. $50, 1.5. 155. So displacement X is 1.85. Okay, T is 1.85 times 10 to the negative 3 seconds. What is initial velocity? Okay. So which ones have initial velocity? We have here, but we don't know V. Here. Oh, do we have a velocity? Accelerates. From the time the ball first touches the mitt. Well thrown ball is caught in a well padded mitt. So time it touches the mitt, so it's saying like here is T. I think it's talking about that point of time. Okay. I think all right. V is the velocity. What's saying 0 equals that times that equals V. Okay, so I don't, that's all I need to know. So we're doing this equation, F3, so 0. And 1.85 times 10 3 10 to the negative 3. So answer is that doesn't really make sense. So they're getting okay, so it's saying the direction. Is asking for the speed as well? I don't think so. All right, let's move on. 51. A bullet in a gun is accelerated from a firing chamber. So a for what is the muzzle velocity? Okay, so V is that plus V naught 0. So V naught, let's say V naught is 0. So we're going to do V 6.2 10 to the 5 8.1 negative 4 0 it's 502 meters per second. A light rail commuter train accelerates. How long does it take to reach its top speed? So we're solving for t. V is 80. So this problem, we're gonna have to convert kilometers, hours, so 80 kilometers an hour. It's above. Right, you need a simplify function. Speed is 80. So it's about 22.2 meters per second. So now we can convert this. Plug this into equation 3 again. So we know phi is 80. We're solving for t. We know it's 1.35. 1.35. And this is t. Initial velocity is 0. 22.2. Okay, so 16 seconds. So it decelerates at take to stop. So we want to solve. We want this to be 0. How do you solve for 0? How long? If you are from its top speed. Top speed is 22.2. So if we solving for t, negative 1.65, t 22.2. So it'd be 13.5 seconds to decelerate. More rapidly. So Okay. You want to come to 0 in 8.3 seconds. So now we're at 8.3. Solving for A. So it's going to be emergency. All right. I guess we'll pick up on 53 next time. We're about out of time here. I guess while I'm here, I can go ahead and add these other two. They're kind of simple. So it's going to be V. So what is this? V average. Yeah, I remember I swapped these. That's why I'm like hesitating. Okay. And next up is this one. So that is X, XX. Okay, so I think these should work. So I'll probably add this to the GitHub. I guess I can delete this, can't I? Okay, so yeah, I will delete this. I will add this to the GitHub. All right, so yeah, I'll add this to the GitHub. And that's, yeah, we'll pick up 53 next time. So I'll see you guys. Have a good one.